So in this question, we're given 4-digit, or we want to find how many okay. So in this question, we're given how many 4-digit positive integers have 4 different digits, where the leading digit is not 0, the integer is a multiple of 5, and 5 is the largest digit. So for a lot of these questions, the reason why a lot of these questions are difficult is because they'll give you a lot of like conditions and restrictions that might be hard to understand or hard to work with. So when you solve like complicated questions like these, you want to like kind of like focus on each condition like step by step, and see what you can like get from each condition. And usually it's a good idea for counting questions to start with the most restrictive condition. And when I say most restrictive condition, that'll make more sense when we actually like start like showing how we can solve this problem. But let's see. So we want to find how many 4-digit numbers there are. So I'll just draw 4 blanks just to represent the 4 digits. So the first condition is the leading digit is not 0. That just means this digit is not 0. It can be any other number though, any other digit. Then we're given the integer is a multiple of 5. Okay, that's pretty interesting. And 5 is the largest digit. So in this case, their most restrictive condition is like the phrase, the integer is a multiple of 5. And the reason that's like restrictive is because that really limits what this last digit can be. In order for a number to be divisible by 5, we have to like have the last digit be either 0 or a 5. Like I think that's like a common divisibility rule. And in case if you don't know that, we'll probably get to that later. And so we want the last digit to be a 0 or a 5 in order for the number to be a multiple of 5. So we can now do something called casework. So we know the last digit is 0 or 5 since the integer is a multiple of 5. So we can kind of split this question into 2 cases. The first case is if the last digit is 0, and the second case is if the last digit is 5. So let's see. So let's write like first case, right? Oops. Okay, first case, right? Last digit is 0. So you have 4 digits and last digit is 0. So in this, like the idea here now is we've taken care of the multiple of 5 condition. And now we have to focus on how can we fill these remaining 3 digits. So the next thing we should look at is we're given that they have 4 different, the digits are all different. The first sentence says they have 4 different digits. So none of these 3 digits in the front can be 0 because we already used 0. And we're also given 5 is the largest digit. So if 5 is the largest digit and we cannot use 0, that means the possible digits that we can use are 1, 2, 3, 4, and 5. Because 5 has to be a largest digit, you can't use 0. So these are the only possibilities. And like basically now, we can kind of like do something called like constructive counting, and notice that like the first digit can be any number like from 1 through 5. So you have 5 possibilities. And or actually, before we get to that, we have to also be really careful. It's true that like the only possible digits are 1, 2, 3, 4, 5, but we're given 5 is the largest digit. So that means you have to use 5. Like you can't only use 1, 2, 3. Like if you said 1, 2, 3, 0, that would fulfill the condition of having 4 different digits. It would also fulfill the condition of not having a leading digit of 0. And it also fulfills the condition of being a multiple of 5, but it does not fulfill the last condition about 5 is the largest digit because you don't have a 5. So that tells us that 1, 2, 3, 4, 5 are the only possible digits, but we also have to use 5. So to count that, we can first take a look at 5, right? We have 3 different spots we can put it in. So that's like 3 possibilities. So let's say we put the 5 like in this middle slot here, for example. It doesn't matter where we put it. It's like basically the same. And now you have 4 remaining digits, 1, 2, 3, 4. And you need to put them into these 2 remaining slots here, like these 2 like empty slots. So the first slot, there's 4 ways to choose from. Let's say you chose like the number 2. Then this remaining slot, you have 3 numbers to choose from. So you do times 3. So in this case, you do 3 times 4 times 3, you get 48. And oops, and now we have like one more case, remember? Our last case is so for the second case, the last digit is 5. So 1, 2, 3, 4, last digit is 5. So remember that we had the rule that the integer is a multiple of 5, and 5 is the largest digit. So again, that means out of these 3 digits, the only possible numbers you can have, or the only possible digits you can use, are 0, 1, 2, 3, and 4. Because you can't use 5 again, and you can't use a number more than 5. So now the idea is, like, if you take a look at this first digit here, it can be any number from 1 through 4. It cannot be 0 because the question said the leading digit is not 0, so you can't use 0. So that tells us we have 4 possibilities for this like blue slot here. So you do 4. So let's say you chose like the number 1. So the number 1 goes there. So you can't use 1 again. Then for this second slot here, the second digit, you still have 4 choices. You have 0, 2, 3, and 4. So you have 4 choices to choose from. And this last, let's say you chose, like, for example, let's say you chose 2, for example, right? So let's say you put 2 there. Then you can't use 2 anymore because you already used it. And now we only have like 3 possibilities left, 0, 3, and 4, to put in this last slot. So you do times 3. And you would get, in this case, yeah, 3 times 4 times 3 is actually 36. Yeah, I don't know what I was doing. 3 times 4 is 12. 12 times 3 is 36. Yeah, so yeah, that gives the right answer then. So you have 4 times 4 times, and yeah, so we have 4 times 4 times 3. You would get 4 times 4 is 16. 16 times 3 is 48. So to find our final answer, we would just combine the 2 cases together. So the 36 and the 48. So you do 36 plus 48, and you get 84 as your answer. And that would correspond to choice D.